Guys, in the previous class, we have started with the concept of transaction management. Basically, transaction means simply a unit of work, right? So, unit of work means it can contain any kind of read operation, write operation, or any kind of modification operations, or simply I can call it can contain any kind of commit operations also, right? So, these operations can be executed on a single machine, or these can be executed on multiple machines. Multiple machines means we can say that multiple transactions, like a particular thing can be executed by only transaction T1, or at the same time multiple transactions are going to be executed, like T1, T2, T3 and so on. Tn transactions are going to be executed. If only one particular transaction is going to be executed, then there is no problem. But the point is, if multiple transactions are going to be executed, definitely your data may yield to some kind of inconsistency. At what situation we are going to get inconsistency? If your multiple transactions are going to be executed in a concurrent fashion, definitely it is going to yield certain situations. It is going to yield inconsistency. But there are certain situations where it is not going to provide inconsistency. That is something like sequential execution. Means T1 can be followed by T2 and so on, or in some other order, right? Anyway, after completion of one transaction, if next transaction is going to be executed, that is what we call as sequential transaction. In sequential transaction, definitely it is going to maintain consistency problem, right? Whereas coming to concurrent execution, means interleaved execution, it may yield to inconsistency of results. For that, we have seen the example in the last class, right? So if you are going to take some read operation and followed by write operation, and interleavingly we are trying to perform the same read operation and write operation. So instead of getting the 250, we got 750. Right? Instead of getting the 250, we got the 750. Right? So this is what interleaving execution. So there are certain situations where it might yield to wrong results. We can simply call it as inconsistency. Right? So if you take T1 followed by T2 or T2 followed by T1, definitely it is going to get the correct results. 250. Random. Right? So what do you like? What you are thinking that how you are getting the incorrect data? Incorrect data రావడానికి chances ఏమున్నాయి? Because there are certain situations like basically if you have a database, on this database multiple people are trying to communicate, right? When multiple people are trying to communicate, if all kind of operations are related to only read operation, is there any problem in the database? No, definitely it's going to just produce the data what they are asking. But the thing is, if the requesting operations contains a combination of write operation and a kind of read operation, first write operation followed by read operation, then there is a chance of getting the problem, right? So means if your request contains write and read operations, definitely it is going to produce a problem. At that situation, what you can do? What is the simple solution? We should not allow all the read operations. We have to allow only for one write operation, right? So or else we can able to have read operation followed by write operation, right? We have to allow complete all read operation, then you have to go for write operation. Or is there any conflicts are available for us? Write followed by write operation, right? So multiple people are trying to write the data something on the database, right? At the time also we should not allow all the people. So this is the case, we are going to get isolation, right? So what you have asked in the last like right now will be explaining this particular thing, right? So write followed by read operation, or read followed by write operation, or write followed by write operation, definitely going to produce various kind of problems for us. We can simply call it as the conflicts which are going to be happen with respect to concurrency execution, right? So we can simply call it as problems of concurrent execution. Right? If you take the first one, what about the other operation? Read followed by read or multiple times read operation. Is there any problem? No problem. there is no problem with this one, so we are not going to discuss about this one, right? So first one is write read conflict. Write read conflict, I mean, if multiple transactions are going to be executed, out of those transactions, one is write operation, another one is read operation on the same variable or on the different variable. Same variable, good, right? If it is on the same variable and both are from the different transaction, then there is a chance of getting write read conflict, right? So this write read conflict, see for example, if I say transaction T1, transaction T2, transaction T2, I am trying to perform some read operation for the transaction T1, read of a variable, and I have performed some kind of operation a equal to a minus 50, and I have updated like this, write of a, write of a. Then after some time again T2 is going to perform read of a, then he has performed some operation like a equal to a minus some 40, and then he has performed write of a, and at the end here also here he have performed some kind of transactions, later he performed the commit operation, right? Is there any problem at this particular transactions? Just think with your religion, is it a problem or not, right? If you are able to observe, there is a conflict called write followed by read operation, right? Why it will be the problem? The point here is, for example, these transactions completely executed, these transactions also completely executed, and at this point of time, if there is any kind of a failure, if failure happen, what will be the meaning? Some kind of network problem, some kind of hardware, whatever it may be, right? Then if any failure is going to happen, according to the transaction states, we are going to simply roll back. Once we roll back the data, what will be happening in the database? The database data is going to be get in the form of actual data only, right? If it is in the actual data, what about this operation? What about the transaction T2 happened? Is it going to be lost or not? Here it is going to be lost because this is not saved in the actual database, right? So this is going to be lost. This update is going to be lost. This kind of conflict I can call it as write read conflict, right? What is the why this problem is arised here? The simple point is because of reading uncommitted data. Am I right or not? Right? So suppose for example, if I made commit here, I am writing in the green mark. If I made commit here, then even after any kind of failures, is there any loss in the transaction T2? No problem, right? So because of reading the uncommitted data, you are going to get write read conflict, right? This kind of conflict I can call it as dirty read problem. What is the meaning of this one? You have to compulsory read the data in such a way that whatever the variable that you are trying to access, it should be first committed, right? If it is committed, meaning that if it is permanently saved, then only you have to allow to read the data, right? So that is what write read conflict. Next one, read write conflict, right? So this dirty read problem, we can also call it as uncommitted readum. Uncommitted read, right? So next one, read write conflict. So in read write conflict, what we can do now? So if you have a transaction T1 and have a transaction T2, we are going to have situations such that read value is followed by write operation, right? So for example, if I say read of some variable a, and here I am trying to perform write of a, and again I am trying to perform read of a. perform read of A, right? Now if you are able to observe, read write conflict means here if I try to read the value of A, assume that the value of A is 80, right? And after some time write of A update with some value as 100, some value as 100. Now if I perform the read of A, what you are going to get? You are going to get the 100, right? The thing is here, in the same transaction T1, he is getting multiple data, multiple reads, right? So this problem we can call it as read write conflict, right? So for the same user at the same instance of transaction, he is getting the different results. If he is getting the different results, we can call it as read write conflicts. This problem we can call it as phantom problem, phantom problem, or we can also call it as unrepeatable problem, unrepeatable read problem, right? So we are trying to read the same data again and again, but for them they are getting the different results. We can simply call it as read write conflict, right? Simply if you would like to define the definition, when a transaction is going to read the same data twice, right? If it is going to produce the different results, we can call it as a read write conflict. For example, if I take some kind of SQL query, right, select star from employee table. Meanwhile, transaction T2 has performed some kind of insertion into some values inserted, right? Parallelly again, he is trying to execute select star from employee. Here he may get 9 records, here he may get one more extra record, 10th record. This kind of thing we can call it as read write conflict. Okay, now. Next kind of conflict you can call it as write write conflict. Write write conflict, right? So in write write conflict, basically you can observe, right, multiple write operations are going to be happen without commit operation. There is a chance of getting inconsistent data, right? So this write write conflict you can call it as lost update problem, right? If I take the transaction T1, transaction T2, I am going to perform basically read operation. I am trying to perform A equal to A minus 50. Again, without performing the write operation, I am trying to perform the read operation again on variable A, right? If I am trying to perform the read operation on variable A, let us say x equal to A into 0.4, A equal to A plus 6. Assume that the A value is 100. A value is 100, right? Now, if I am going to perform here write of A, what is going to be happen? Basically, at this particular step in the RAM, we are going to get the 100 value, and it is going to be 50. The A variable value contains now 50. It is not updated in the local also, right? When it is going to be updated in the local, when the write operation is going to be executed, right? Now, coming to here what value you are going to get? 100, then 100 into 0.4 is 40, then it will be 140. It is also not yet updated, right? Then after this one, we are trying to perform write operation. Suppose for example, some commit happened here, and after this, here also some commit happened, right? Now this situation we can call it as write write conflict, meaning that one write followed by another write. See, these examples doesn't like exactly define the entire scenario. You have to understood that here, when a write operation followed by write operation, definitely it is going to have conflict. Similarly, read followed by write or write followed by read, definitely is going to produce the conflict operation. That is what I am trying to convey here for you. Right? This kind of problem we can call it as write write conflict or last update problem. Why last update the problem? Right? So if you are going to say that if something is going to be failure here, again what might be happen, right? So here it will be 140 because of this commit operation. But what about at this particular step? It is going to get back to again 100, right? So earlier the value of A is 100, so we are going to update in the database also as 100. So here what are the operations that we did, those updates are going to be lost. That's why we are call it as lost update problem. Okay. Next kind of problem is there, which is a general thing, incorrect summary problem. Incorrect summary problem. So the meaning of incorrect summary, so which is as like as read write problem, right? So in read write problem we are going to make unrepeatable reads, right? Multiple times if you are trying to read the data for the same transaction, you are going to get multiple different results. Whereas coming to summary problems, when you are trying to perform some summary over the transaction, one transaction will get one summary, other transaction will get another summary because of some write operation done parallelly in other transaction. Am I right or not? Right? If I take the transaction T1, transaction T2, and if I am trying to perform sum of, let us take marks, we got certain data, and in the transaction T2 some admin trying to set marks to some value. Meanwhile in the same transaction I am trying to perform again sum operation, right? This is what simply like during the summary of some problems also you may get incorrect data. That incorrect data because of some kind of again updation problem. Okay, and there is one more kind of problem is there in this concurrent executions, that is unstable cursor problem. Unstable cursor problem. So unstable cursor problem means, see for example I am trying to perform select star from employee where employee ID equal to 535, where employee ID equal to 535. Okay, so there is no problem for this one. But unstable cursor means while users are working with their own data, if admins or some other people who has access to the database, they are trying to delete some attributes. They are trying to delete some attributes, right? So those attributes can be again EID attribute, right? If EID attribute is deleted, what about this particular seat response? There is no such attribute, error you are going to get, right? So this kind of problem we can call it as unstable cursor problem, right? So concurrent execution problems means it is not only about like various kind of read write, write read or write write problems. It may also include the unstable cursor problems also, because if any modifications are there in the database at the administration level, those modifications can be reflected in the user level also. So you have to take care of all these kind of problems. Okay. So if I have a summary, why write read conflict is going to be occurred? What is the reason WR conflict is going to be occurred? Because of reading, very good, reading uncommitted data, we are getting write read conflict. Similarly, why you are getting read write conflict? Because same transaction contains multiple read operations, we are getting the read write conflict. We can say that two different values are getting for the same read operation, for same read, we can say that it is read write conflict. Similarly, write write conflict. So write write conflict means when there is no intermediate like read operation, then you are going to get write write conflict. If there is no intermediate read operation, then you are going to get a chance of write write conflict. But if there is a commit, there is no problem again, right? According to multiple scenarios may be existed. I have written only one scenario here, right? So if in between these two, so for example after write of A, if you are going to have commit here, is there any problem? There is no problem, because it is permanently saved, then he is trying to update the data. So that like this we have multiple situations, right? So what is another problem? Incorrect summary. Why you are getting the incorrect summary? Because when you are trying to perform update operations over summarized values, we are going to get incorrect summary problem. What about the unstable cursor? unstable cursor. If you are going to delete some attributes in the database level, you are going to get unstable cursor. So deleting attributes from the database, we may get the chance of having unstable cursor, right? These are the some of the problems that you might occur when you are going to go with the concurrent execution, right? So is there any is all these kind of problems are occurred in the like normal execution, like sequential execution? There is no problem, because once the entire transaction T1 done, then only we'll move for the transaction T2, right? If you would like to technically define like how they will write now, read one of A. What is the meaning of this one? Read operation I am performing over the transaction 1 on the attribute A. The attribute A, right? Similarly, if I write something like write 1 of A, right? Write operation over the transaction T1 on the attribute A, right? Is this a kind of conflict or not? Is it a conflict? Yes, it is conflict. Why it is conflict? So it is not conflict. Why it is not conflict? Because on the same transaction. Very good, right? As it is on the same transaction, even though it is on the same variable, there is no problem. But if I say read operation on the transaction T1 and write operation on the transaction T2, then definitely there is a conflict. What is that one? Read write conflict is there, right? For example, I am just giving the clues here. Read 1 of A, write 2 of B. Is there any conflict? There is no conflict. Why no conflict? Even they are of like read write combination, they are working on different data items, right? So like this we can able to have many kind of combinations, right? You have to make sure that, right? Okay, so here we have seen various kind of problems are there, right? We have seen various kind of conflicts, right? To overcome these conflicts, we are moving for a concept called schedules. Schedule, right? So what is the meaning of a schedule? Right? Scheduling means basically we are going to simply define the order in which your transaction need to be executed, right? So with your like earlier knowledge, if I am going to execute T1 followed by T2, is there any problem for you? No. Or T2 followed by T1, there is no problem for us, right? This is something like a kind of scheduling of execution of the transaction, right? Simply the order in which the transaction should be executed, we are going to define that definition, that thing we can call it as scheduling in the DBMS. The order in which your transaction need to be executed will be defined by the schedules, right? So basically these schedules are of two types. What are those? One is sequential execution, or I can call it as serial execution of the transactions. Another one is concurrent execution of the transactions or interleaved execution of the transactions, right? Earlier we have seen already, right? Suppose for example, if I am going to have a transaction T1 which may contains two data items A and B, and I am trying to perform read operation over the X and write operation over the X also. If I am assuming that X is the data item, right? So how can we represent this R is related to T1? I can write as R1 of X. I can write it as W1 of X. By simply seeing this one, we can able to understand that write operation is for the transaction T1 on the data item X. Similarly, if I am going to have transaction T2, read 2 of X, write 2 of X. These are the two data items and these are the operations that we are going to perform on the transaction, right? Now, if you don't have to get any kind of problem, what we can do? We can go for execution of the serial transaction, right? Serial execution. So what we can do now? T1 and T2 are the two transactions are there. First I will execute the write 1 of X, write 1 of X, followed by read 2 of X and write 2 of x. There is no problem here, right? Similarly, the case is first T2 is going to be executed, R2 of x, write 2 of x, R1 of x, write 1 of x. Is there any problem in this particular situation also? There is no problem because they are serially executing. They are serially executing. Now, coming to the scenario of concurrent execution. In concurrent execution, what might be the different possibilities are there? T1, T2 are the two transactions are there, assume. What might be the scenarios? In which order the transactions are going to be executed in concurrent execution? For example, first read 1 of x done, right? Some IO operation is required, then it will be handed over to read 2 of x, right? Some IO operation required, write 1 of x, some IO operation required, write 2 of x. At the end is going to happen what? All the entire transaction is going to be completed, right? This is one of the possible scenario for concurrent execution. Right? I am trying to write here various possibilities. If I take here one more way of executing this transaction T1 and T2, read 1 of x, read 1 of x, read 2 of x, and I am trying to perform write 2 of x, then write 1 of x. See, like this scenario is possible? Yes or no? Yes, there is a chance of possible this scenario in concurrent execution. What might be the another possibility? So like this, if you are going to write, how many possibilities are there? 5. Like only with respect to concurrent execution. Don't worry about the serial execution. Right? If you check this one, inner things are there. First, let me start with R2 of x. R2 of x. Then followed by R1 of x, write 2 of x, write 1 of x. Is this situation is possible? Yes or no? Similarly, inner things are there. T1 followed by T2, R2 of x, R1 of x, write 1 of x, write 2 of x. This is also one more scenario possible. So any other things are there? No, all phases are covered, right? So meaning that when you are going to have two transactions T1 and T2, both having read and write operation on single variable, then you may get 4 different ways of concurrent execution. Meaning that we have written all the possible executions of the system, right? So how many concurrent executions are there? Right. So let me tell how many serial transactions are there when you are going to have two transactions T1 and T2. 2 types of possibilities are there. What about like if I am going to have T1 and T2, both are having 4 instructions. 4 instructions which is a combination of read as well as write. So total how many possibilities are there here? 4 possibilities. Right? Can we generalize it? Right? For example, if I am going to have n transactions, T1, T2 and so on, Tn transactions are there. How many serial schedules are possible? 2 power n, right? So you are going to have n factorial ways, right? So means if you want, you can just cross check. T1, T2, T3 are the 3 transactions are there. First one is T1 followed by T2 followed by T3, right? Next T1 followed by T3 followed by T2. Like this, you have to write all the possible cases. Now the situation is, let us check T2, T2, T1, T3, T2, T3, T1. This is one more possibility, right? Another possibility is what? T3, T1, T2, T3, T2, T1. Any other possibilities are there? Yes sir. No, right? So that is the reason I have written, like if I am going to have 3 transactions, how many serial schedules are possible? 6 serial schedules are possible. That is what this example clearly defines for you, right? If I am going to have n transaction, n factorial serial schedules are possible. Serial schedules are possible. What about like concurrent schedules or concurrent or interleaved transactions? So simply we can write, like for example, if I am going to have T1 contains n operations. Earlier we have two operations, one is read as well as write operation on the variables x, and T2 contains m operations are there. Then we can write like this, right? So total number of serial schedules as well as non-serial schedules. Like non-serial means what? Interleaved execution or concurrent execution, right? So how many means, simply we can say that n plus m factorial by, this is important, n factorial into m factorial, right? Meaning that total number of schedules possible. Total schedules possible for the transaction T1 and T2 with n operations as well as m operations. We are going to get n plus m factorial by n factorial into m factorial. If you want, you can just check with the earlier one, right? So earlier we have two operations, here also two operations. So 2 plus 2, 4 factorial, 4 into 3 into 2 by 2 factorial into 2 factorial. So total 6 schedules are possible, right? So if you are able to clearly observe, serial schedules are 2, concurrent or interleaved schedules are 4. Total 6 schedules are possible, right? Suppose for example, if you are going to have like multiple transactions are there, like n transactions might be there, right? Now it's not only about two transactions, like T1, T2, T3 and so on, Tn, where every transaction contains A1 operations, A2, A3 and so on, An operation. Now tell me formula for total number of schedules possible. Total schedules A1 plus A2 plus and so on, An factorial by A1 factorial into A2 factorial into A3 factorial and so on, An factorial. This is the formula for to calculate total number of schedules possible on the given transaction data items. Okay. And so this is total schedules, right? Total number of serial schedules. Total schedules is different from total serial schedule, right? So total serial schedules are how many? N factorials, right? So if I am going to have T1 to Tn transactions, total n transactions are there, n factorial ways are possible for this, right? Now can you tell me the total number of non-serial schedules? Non-serial schedules, right? So simply we can write as total schedules minus total serial schedules, right? So this particular slide is very important for you. Okay, so basically if you take these schedules are classified in different ways, right? The way, based on their characteristics, they have classified into different ways. Among those, first one is, which you know already, serial schedule, right? Serial schedule means each and every transactions are going to be executed one after the other. The other possibility is what? Non-serial schedule, right? If you look into more in depth about this non-serial schedule, they are again classified as serializable schedules, and another type is non-serializable schedules. Just write the chart. In the coming class we'll explain non-serializable schedules, right? Again, the serializable schedule is classified as conflict serializable, and another type is view serializable. Non-serializable schedule classified as recoverable schedule, another one is non-recoverable schedules. Again, these recoverable schedules are classified as cascading schedules, and cascade-less schedules, and another way they are going to call it as strict schedules, right? So anyway, we are going to have everything will becomes under non-serial schedules only. The way that you are executing based upon certain kind of characteristics, they are going to be classified into different ways. Okay. Right. So basically, guys, what is the meaning of a serial schedule? Right. Serial schedule means basically there is no interleaving of operations. So completely after completion of one transaction, then only we will go for another transaction. So up to now we have seen all those, right? So simply we can say that T1 followed by T2 followed by T3 and so on Tn. So order may be in any manner, but one transaction should be completely executed, then we will move for another transaction. We can simply call it as serial schedules, right? So these serial schedules always set your database in the consistent mode or inconsistent mode. Consistent mode, right? So whereas coming to non-serial schedules, they may be generate inconsistent modes also. May generate inconsistent modes, right? So what is the meaning of non-serial schedules? Which you know, right? We can simply say that interleaving of execution is allowed. Execution allowed. We can call it as non-serial schedules, right? So again, these non-serial schedules are classified as serial as well as non-serializable. So what kind of schedules we call it as serializable schedules means? So let us go for that. So serializable schedules, right? So guys, basically why we are moving for non-serializable schedules rather than serializable schedules? To make server utilization is more, right? If you want to utilize the server at maximum capacity, we are moving for non-serializable schedules, right? Even it is producing the incorrect data, but we have to always make sure that to get the correct data, right? For that reason, whatever things that we are trying to write as part of the serializable schedules, those has to be produce correct results also, right? So for that reason, what they are saying now, serializable schedules means if I say a non-serial schedule, non-serial if I say non-serial schedule, yes, and a serial schedule S dash, both has to have satisfied certain kind of properties. We can say that they are serializable schedule. What are those properties means? Simply, they both have same number of transactions. First point, they both have same number of transactions. Meaning that if I take one serial schedule S dash, another one non-serial schedule S, if I want to say that these two are equivalent, we have to say that both schedules should have compulsory same number of transactions. That is first and foremost important point. And they have the same impact on the database. Am I right or not? Right? So basically, serial schedules are going to produce always correct data. Right? If I want to include the non-serial schedule is equivalent to serial schedule, non-serial schedule also has to produce the same data on the database. That's why I have included these 2 points. Then if it is satisfied these 2 points, I can call it as serializable schedules. So indirectly what I am trying to do, I am trying to find out the schedules in such a way that which kind of interleaved schedule may be equivalent to one kind of the serial schedule. Am I right or not? Right? So that is what the definition of serializable schedule. Right? Basically, the serializable schedule can be defined in terms of 3 ways. One is in terms of result, we can call it as result serializability. Result serializability, or we can call it as result equivalence. Result equivalence. In another manner, we can say that conflict serializability. Another one is view serializability. So these are the three different ways we can able to define one non-serial schedule and another serial schedule may be equivalent. We can define in terms of result, meaning that at the end of the non-serial schedule S dash and serial schedule S, if the result is equivalent, we can say that both non-serial as well as serial schedules are equivalent. Or we can say in terms of some kind of conflict operation. Conflict operations, what might be there? One is read write, write read, write write. In terms of these also we can define the two schedules are equivalent or not. And in other terminology, we can say based upon the way they are appearing, based upon by simply viewing the transactions, we can define whether they are view serializable or not. Right? So if we look into the first one, result serializability. So result serializability or result equivalence means if the output of the serial schedule, right? Simply if the output of the serial schedule is equivalent to output of the non-serial schedule. So output of serial schedule and output of non-serial schedule, both result is completely equivalent, same, then I can say that they are result serializable, meaning that in terms of output we are defining their characteristics. Right? For example, if I take transaction T1, transaction T2, here I am trying to perform first read of operation on the x variable, and then x equal to x plus 5 w of x, read of y equal to y plus 5 write of y, and I am going to write some other operation in the T2, read of x equal to x into 3, and then write of x. Assume that my x variable value is 2 now. My x variable value is 2, y variable value is 5. Right? Now guys, tell me, is this representation is serial or non-serial? Serial means after complete execution of the T1, we are executing the transaction T2. Now what might be the result for this one? Right? X value is 2, y value is 5. Right? So what might be the value? Right? Here you are going to get the data 2, here you are going to get the value 7. That 7 is going to be updated in this local RAM, not the global, right? Not in the database, right? Local RAM updated. Next read of y is 5. Next y value is again 10. That will update in the locally 10 value. 10 value, right? Now, so if I try to read the value of x, what might be the value? 7. And here the value is 10. That will be updated in the local variable 10. Right? So I hope you understood why I have directly taken here 7. Because transaction T1 is completely done. Done means what? At the end, you may consider it as commit also. Right? Meaning that it is globally updated. Okay now. Then we got this data. Now what might be the value? 7 3s are 21, right? 21. That 21 is going to be updated in the x variable. Right? So at the end of this transaction schedule, your result is going to be x value as 21, y value will be 10. Y value will be 10, right? For example, if I take the another scenario, so which is a kind of non-serial schedule, T1 followed by T2. If I say read of x equal to x plus 5, write of x, some kind of commit operation, read of x equal to x into 3, write of x, some kind of commit operation. So here we have some kind of statements are there. Something like read of y equal to y plus 5 and write of y. Right? So meaning that the same representation of the T1, T2 for the serial schedule I have written in terms of some kind of interleaved fashion. When you are going to write in the form of interleaved fashion, definitely is going to give more yield in terms of CPU utilization. Right? Now tell me what is the output you may get here. Here it will be 2, then it will be 7. That 7 will be updated in the globally, right? Because we made commit here, global update. Right? Now what about this transaction? Here you are going to get 7, here you are going to get 21. That will be updated globally because of commit. And read of y value is 10, write of y. At the end of these transactions also, x value is again 21, y value is 10. So at the end of this, one is serial schedule, another one is non-serial schedule. The result is equal. Then I can say that these two schedules are result serializability or result equivalence. Right? Now between these two, which one you will prefer? Non-serial, because it may yield more performance, meaning that it can execute within the less time also, right? Compared to serial schedules. Okay now. But the problem with this result serializability is, so one problem is there, they are going to be highly which we can say they are highly dependent on the input sum. They are highly dependent on input variables. What does the meaning of this one? If I say something like read of x and x equal to x plus 10, x equal to x plus 10, and the same thing I can be written as read of x equal to x into 1.1. Can I write? For example, if I say 100, the value of x, what might be the x value now? 110. X value is 110 now. Good. X value is 110. But if I take this transaction T2, assume that another transaction, read of x is 100. 100 into 1.1 is again 110 only, right? So again it is 110. So but the thing is, can I say that T1, T2, these different type of transactions are equivalent, result equivalent? No, because it has satisfied for only certain set of inputs. Take out the case for, instead of take out 200. Instead of 100, take out 200. 200 if you are going to do, what might be the result for the first operation? 210. What about the operation for the second operation? 220. Right? Meaning that for certain kind of inputs it is going to be satisfied, but for some other kind of inputs it is not going to work. That is the problem with the result serializability. Right? So at the end what you have to understand now? So if the results are same, I can say that result equals. That's it. Right? But the problem here is they are highly dependent on inputs. The variables what you are using, they are going to be affected also.